Hello YouTube viewers, welcome to my channel S2T. In today's show, Future Friday, we're gonna talk about Hyperloop scam. So let's dive right into it. Well, first you have to understand what we are talking about. We are talking about something that I already made a video about in 2018, and this is a 2-year follow-up, so to say. So let's dive a closer look at this. Well, this is a presented in front of a public as a Elon Musk idea, a dream of Elon Musk that was released to the public in 2012, and white paper followed quite quickly after that. However, that was the first red flag, is that given the fact the whole Hyperloop concept is taken wholeheartedly from Robert Goddard, aka granddaddy of rocketry, and the idea was made in 1910. So this is something that should set up a alarm bells, and he never corrected that, like, oh no, this idea is an evolution of that with better technology. No, this is like, oh, I have this dream. No, you don't have that dream, you directly copied it from this. So that should be the first red flag. Now, what Elon Musk was offering to the public was basically the USP. What is the unique point of making a Hyperloop was that it's gonna be cheaper than a train, specifically even cheaper than a bus. Like, that was the stretched point, but the idea was if you made a high-speed railway network, the ticket cost would be much more expensive than this. However, not only it's gonna be cheaper, it's gonna be faster than an aircraft, aka must be traveling at higher speeds than 700 and 800 kilometer per hour. So that's what we are talking about here. Now, again, any Tom, Dick, and Harry can come up with the designs, dreams and desires and CG effects and all that. So, what is the science behind it? The science behind it, the early designs were very bad designs. They were because they were using instead of using maglev, they were using hoverboard design. And first of all, ask any of your military friends. They are like, dude, hoverboards. Like, military have boatload of them, but they are very inefficient. They are only used in last ditch resort. It's like, we can't save petrol, diesel here. Yeah, just use hoverboards. So flat out, that design was scrapped, and that was the second sign that you were like, dude, how the heck you can release a white paper that has a flawed design in it? Then people quickly switch to basically maglev propulsion. Now in maglev there are many designs. 3-4 of the designs are there. However, the people realized very quickly is that per track cost per kilometer would be ludicrous if you want to use maglev. On top of that, maglev is very energy intensive. Sometimes people see, oh, maglev trains or Shinkansen going by, and they do not have see diesel plumes or things of that nature. They're like, oh, these are clean and green. Well, no, simply because they require a lot of energy. Lot of energy. Now, Japanese countries at this point in time, they are in a unique position where they run both of the system and give you complete numbers on that. Because I cannot compare German system to Japanese system because there are too many variables. But Japanese system to the Japanese system is more comparable. So I'll give you a quick rundown of the energy consumption. How much energy you're talking about here. So to run this maglev system at 500 km per hour, because that's their service speed. They can travel to 600, but 500 is their servicing speed. Basically, that when your track times will be given, like, okay, it's gonna take you 1 hour to reach the next destination. The speed for that kind of ticketing, so to say, is 500 km per hour. So that will consume 100 kilowatt, basically 100 watt hour per seat per kilometer. So taking one passenger in this craft is like equivalent of consuming 100 watt hour power for 1 kilometer. So that's for the maglev system. Now for the Shinkansen, the wheeled system, this is at 300 km per hour. The power consumption is 29 watt hour per seat per kilometer. So as you can see, like, maglev just not magically is more efficient. It requires more power to travel at higher speed, and you can easily see at 300 km per hour you are consuming more or less 30 watts watt hour. Of course, that 30 watt hours does not, like, you are not tripling the power requirement, but you are not tripling the speed. You are not traveling at 900 km per hour, you are still traveling at 500. Now that happens because of the atmospheric drag, but this should be the first point where you're like, okay, maglevs are not just magic technology, they consume insane amount of power. Like, your electricity bill running on the maglev system would be huge. So the high cost is there, always there, just by the fact that track cost per kilometer is ludicrously high. Then the energy cost running it per kilometer, like at a given speed, would be high, and it will not just magically disappear even if you put in a vacuum. Why? Because if you put in a vacuum, you do not change the mass of the craft, so inertia is still there. You have to accelerate and decelerate. That will take energy. On top of that, you are still in a gravitational you are not in a vacuum, not in a free falling environment. So the gravitational drag also adds insane amount of energy because you're always fighting the gravity. So the reality was that when Japanese people realized this and they built the system, their budgeting came around $80 billion for 300-kilometer long track. Now, if you're like $80 billion for 300-kilometer track, that sounds way too steep. Well, yeah, it is. Now, there are two reasons that are compounding this kind of cost. So it's not just maglev equals 80 billion. One of the problems is like Japanese, where they want to make the tracks. First of all, the track has to be ludicrously straight. It has to be like so straight that you fire a laser pointer, it will reach to the last station. It has to be straight as hell. Then the turnings and banks and all that, they have to be much more smoother and gentle compared to normal Shinkansen. And because of the turning radius requirement, they are like just drill through the mountains. It was much more cheaper approach. So cheaper approach is $80 billion. So reality is very serious. The maglev technology, yes, there have been like at least 20-25 maglev technologies that has been built, put to the service. Most of them have been closed, and people just realized early on the maglev on paper sounds amazing. In reality, it's like it consumes so much electricity. It's like, yep, it's not free. And not to mention the capital cost on maglev systems are astronomical, because even if you may think like, okay, making a absolutely stable railway tracks for normal track, basically Shinkansen is expensive. Making a absolutely straight concrete track which has magnetic coil in each of them, every segment has magnetic coils, and you have to design with sensors, electrical supply systems and all that jazz, that's gonna be cheap. Yeah, not possible. And there are other designs which use permanent magnet. Side effect of them could include from not able to reach very high speed. There is a reason why there are so many maglev systems. Some systems work at 0 speed, others like this one requires you to have wheels. Basically it is like as a landing and launching system, so it has to be pushed to 150 km/h on normal motors. Once it reaches that, then the wheels fall. It's almost like an aeroplane at that point. It takes off and lands. So this system allows the highest speed. So if you want to make a maglev and you're like using permanent magnet system, you will find the electrical requirement to be ludicrously high, either on the pod itself or on the track. The moment you have to put energy system on the track, because it's not that you are floating, you have to travel fast, otherwise there is no point in it, because the system is already too expensive compared to a plane. So to gain the speed, quote unquote speed, you have to consume a lot of energy. If the energy comes from the onboard batteries, again, there is no battery system that is energy dense enough to provide like 100 watt-hour per seat per kilometer. Multiply that by like whatever you are thinking about, like let's say 500 passenger or 500-kilometer journey. That's insane amount of power requirement. So the reality is maglev inherently is very expensive. That's why you don't see it everywhere. It's just like, yeah, it costs billions of dollars and it does not even save on electricity bill. Then we come to the vacuum aspect. This is the aspect that was like final nail in the coffin. Till this point, everything is like, yeah, we could do it one way or the another. We could do it one way or the another. There are people who are running on it. It's just that the moment is you add vacuum tube, you have to realize this. They want to achieve absolute vacuum, but it's not feasible to make vacuum tube the size of a train. It's not possible. Like flat out, air will find always a way, because you have to understand, the bigger chamber you make in a vacuum, the more pressure outside environment will exert. So if you think like, okay, normal Coke bottle can handle vacuum level pressure, it can in one way or the another. And if it's perfectly straight, it can handle it. The moment you make the surface bigger, the atmosphere gets more stronger and your surface becomes weak. And you can easily see that in Mythbusters experiment. These are train tracks. Basically train carts, and they are designed to handle train collisions. They are strong puppies and they have thick steel walls, not some like or tin foil. This is very thick, and they try to bend it with a vacuum. Nothing happened. They're like, I got this. However, if they had even a minor dent, and they tried this with like dropping a concrete block, if you had minor dent, let's say in case of Hyperloop, some train crashed to the pylons of the structure, minor dent resulted. And this happens. This is the reality of it. Vacuum literally makes your structure unstable. Now, the reason for going to the vacuum, and they will call it low pressure simply because you cannot achieve 0 psi. Like you cannot, like 15 psi sea level, you can go to like let's say 1 psi, 0.5 psi, 0.3 psi, like going from 0.5 psi to 0.3 psi will require your pumps to run overnight. And like the chambers that NASA has for testing in spacecraft, it takes like megawatts of power to go down to that absolute zero. That is very difficult. So they know for a practical reason you can't achieve 0 psi. So they're like, it's low pressure. It's almost vacuum. They are targeting like 200,000 feet altitude. It's almost vacuum. So air is the primary source of friction. It is the like energy drag that is happening on your maglev pods. but it also acts as another system. It's a speed limiter. That is why planes are generally traveling subsonic, because once you are subsonic, the energy drag is always there. The friction that is happening is equal to atmosphere. But the moment you increase the speed, there is a sound barrier. That barrier will drastically increase your energy spike. Basically, the energy required to break through it goes up dramatically. So like, you're just to break through, you will require like 8 times more power. Once you are broke through, once the airflow over your airfoils is absolutely supersonic, then it calms down. Then it's like, okay, now normal system. But because of that, you cannot travel very fast, or like you have to expend so much energy that you have to fire afterburners in a jet engine. So that's the reality. Not only air is adding like, energy drag, it's also limiting your top speed. To how the heck you increase your top speed, you remove air. So that's the point. It's like it will make maglev more efficient, and it will increase your top speed, so you can truly achieve that, faster than aeroplane. However, vacuum requires a lot of energy. There is an old saying, like you never get something for free. So to achieve that vacuum on a giant tanks, like you can get some idea of it, that Virgin Galactic, when they built there's like close to the full scale as you can get. Those take like the pumping house there is, it's huge. The pumps in running in it, huge. They consume kilowatts of power like there is no tomorrow. Like those are energy hogs to run the vacuum pumps. On top of that, not only you have to have those pumps, you have to keep them running simply because to maintain it, because everything will leak. And the another aspects you have to understand, when you are talking about something huge, you cannot think of it as a one unit mass. Basically, it's not one thing that expands and contracts, expands and contracts. It will be like multiple small sections will expand and contract differently. That's a big issue with train tracks. That's why you will see railway tracks having gaps. That's why you will see basically bridges, flyover, all of them have gaps. How the heck you gonna have a gap in a vacuum tube? There are some ways to go around it, but none of them are cheap. All of them will make your track cost, because of the maglev already is too high, making a vacuum tube that expands and contracts much more expensive. It's a number that people are not understanding. That you are talking about $1 billion enterprise just to make a pipe that can expand and contract properly. And here's the it will not be an issue in one day. The structural integrity of a structure will hold it, like the steel itself will hold it, but over time it will fatigue. And you are talking about, like, let's say 2-3 years down, it will randomly give up simply because it has fatigued too much. It happens with anything that is like, relying on brute force to handle that expansion contract. That's why we use joints. We have learned out, like, you can design a structure that's like, holding it on and all that. It can be done, but it fatigues the material. That's why nobody wants to do that. And you want to handle atmospheric pressure and have it something going inside it, so you have to make sure inside is absolutely smooth. So you cannot have a, like, oh, there is a peak going and bam, your pod will turn to chunky sauce. So vacuum requires a lot of energy, and you have to run the pumps continuously to maintain it, because this is the one thing that frustrates me to no end. I'm a CG artist, so I can see CGs and all that. None of the CG drawings from every single company shows a airlock. It's like, oh, the train is traveling in vacuum pods and tada, station. Where was the airlocks? You need multi-stage airlock, otherwise your pods will directly go from 0 psi to 15 psi. That will be damaging to the pod one way or the another. Airlocks are not cheap, not to mention they are energy intensive. Again, you are talking about something that can handle a full atmosphere versus a full vacuum. Again, International Space Station has those are expensive, and you can easily see in the Virgin Galactic, they are the only one where you can easily see there is a airlock segment. It's very big energy consuming, and all airlocks leak over time. Again, if you are talking about a giant 200-kilometer sector, how many airlocks you're gonna have? You definitely don't want to have like only one or two at the other end, because that means any fault happens in any part of the track on 100 kilometers, you did. So to understand that, not having even a single airlock, nowhere I see airlocks in any of the animation. How the heck you're gonna handle, let's say some damage happens, something happens, earthquake could be sometimes so powerful it will damage things. We were like, oh, earthquake, so we can handle something. No, you can only handle, let's say, 6 magnitude earthquake. What do you do when you hit by 7? So Japanese people learned this the hard way. It's like they designed a train that's like, no matter what happens, it does not derail, but it derailed because one time earthquake was too powerful. After that, they realized they're gonna put anchors into bottom bogies, so that anchor will catch onto the track itself, so it will not topple over. So they realized, like, the trains are very safe, but the moment it topples over, rescuing people becomes an issue. So they made sure that anchor will grab the track itself and not topple over. So you have to understand, you have to design your system in such a way that they're like, oh, if this fails, this will I do. If that happens, this will you have to do. Because you have to understand, you're not talking about one person going inside, right? It's not like 14 astronauts who are like half of them are from military, they understand the risk and all. This is common people. They expect to get into a system, get out of it alive. It's not 1910 anymore. It's like, oh, I'm going into Atlantic, I may reach the other end, or may just disappear on the between. It's no longer acceptable. So not having expansion joints, again, if you don't do it, it will damage your materials. If you do it, it will make it ludicrously expensive, and airlocks are always leaking, so you all gonna need continuous maintenance cost on that, and then everything becomes unsafe in that, because again something happens, let's say a fault happens, something happens because satellites breaks down. Those are the most expensive things we build, even those breaks down. International space station have faults, things happen, bad things happen, no matter how good you are. Now how are you going to rescue system, because you can't just open the door and walk out. That can happen even in a tunnel system, let's say train catches on fire, somebody pulls the emergency, people can just open the door, walk on the side of it. All the tunnels have the option for a passenger to walk out of it. You cannot do that here, because the moment you open it, you're going to die inside. Why? Because it's a vacuum, you're going to suffocate. So rescue is not possible, and no mention of how the heck the system is gonna be breathing. Like, does it have internal liquid oxygen system? Because some fighter jets have that, because they travel so high altitude, they have to carry their own liquid oxygen, because getting an air from compressor is just too inefficient. So they do that. Are you gonna do that? No. How the heck you gonna handle it? Let's say for some reason everything is intact, like there is no catastrophic damage. How the heck you gonna breathe in case, like they say this place gets stuck in around for 2-3 hours? How they can breathe in it? Then another aspect, how the heck you're gonna handle fire? Now I'm like, how the heck there will be fire if it's in a vacuum? There is no oxygen. There is oxygen in the pod, because if there was no, human would be dead. And vacuum is a perfect insulator, as close to perfect as you can get. So that means the heat from any fire event, let's say batteries catching on fire, or some dude had something faulty equipment and that caught on fire, the heat would be so intense it will cook people alive. So how the heck you gonna handle that? No mention of that. It's like, nope, we're just gonna magically work, and if something bad happens, yeah, you did. Then we come to the another aspect of it, the expensive cost of the Hyperloop system, and it's like ludicrously expensive. The white paper was like criticized by every single business analyst, every single project manager. It's like, dude, this is fantasy price. It cannot be done on this price. This will be much more expensive. So once you take that into account, you'll be like, how the heck I will pay for it? One simple answer: more users. So you created a big expensive server. How do you pay for it? You make hundreds of people use it. Awesome, simple system. Here's the deal: the pod inherently does not have the carrying capacity. It does not even have carrying capacity of a normal, low scale jumbo jets. You are talking about like 60 passenger, 100 passenger at best. That's not enough, because let's say in case of India, we are talking about Indian trains are carrying on average 1,000 people. Basically Sankirtan train systems, bullet trains, basically they are carrying around 1,200 people. So you can get the idea. Whenever you are building expensive things, you design in such a way that it carries services the most amount of people, so per ticket cost goes down. This is not that. This is a luxury show off. This is not the final product, because if this was the final product, the ticket cost would be so high, people like, no. Of course people will pay, I traveled in Hyperloop once in a while, but it's not gonna be something like that. And pods gonna be claustrophobic on a different level, because you have to understand, people will say, hey, it will be like in an elevator. Again, if elevator gets stuck, damaged or anything, you can go out. You cannot do anything like that in this if it's inside the pod. So that's the whole point. Another aspect is, whenever you have something like this, you will be like, okay, it will keep running on for a very long time, and that way we'll get our money out, because inherently it's sealed. It's not gonna deal with atmospheric drag. It's not gonna deal with weather or temperature changes and all that. So you will think the pods will last forever. No. Why? The pods, the biggest issue is the air pressure inside it. Now this is the ask any of your friend who are dealing with aircrafts. They will tell, like, the biggest issue with aircraft, airlines do not want their plane to take off and land very quickly. They want long journey flights. Why? Because the plane will last longer. Why? Because fatigue happens whenever you are going from sea level. Let's say in aircraft, sea level is 15 psi inside, 15 psi outside. Everything is happy, everything is stabilized. The moment you go up, again, humans cannot breathe in low psi, so they generally pressurize the inside. Now they do not pressurize it to the full 15 psi, otherwise your ears will not be able to tell whether you are taking off or not. So they pressurize it to 7 psi. But outside pressure is much lower than that. It's like reaching around 8 or 9. I'm saying very lower than that. So the change in pressure inside and outside can be as high as 7 psi. So there is 7 psi pushing outwards. So it's expanding like a balloon. Now once you are doing the landing, this contracts. Taking off, expands. So this expansion and contraction fatigues the metal on a microscopic structure, and it over time it degrades the material. So you can have a plane from like 1960 or 1970 and be like, hey, it looks absolutely intact. It would be intact. It's just they would have done pressure testing and like, yep, this is in the last leg. It's like, nope, it's gonna be retired. So many times you will see, like, aircraft graveyards and planes are completely intact. That happens. It's like this fatiguing destroys the material on a microscopic structure, and you will be like, okay, I'm gonna use carbon fiber. Even carbon fiber degrades due to this. Repetitive stress will destroy anything, no matter how strong it is, which includes diamonds also. So when you are talking about a pod which has to go from 0 psi to 15 psi again and again, because inherently your journey times would be 20 minutes or 30 minutes, so every 20-30 minutes is doing this, it's gonna fatigue so quickly. So it's like, oh, this is the pod and we're gonna use it for 1 year, everything is awesome. Second year, the air compressor keeps running on for much longer, and 3 years, yeah, the pod is totaled. I have to build a new pod. So that's the reality. The pods will not last longer due to this expansion and contraction. Inherently nothing will last this long. Like the only thing that even comes close to handling this would be Starship, and they are designed for, like, 40 reviews. So that's the reality of it. It does not have the capacity to justify the cost. Now, when I say the word scam, you have to understand, I'm just following this for a very long time, and I was sucked at, the hype of the Hyperloop. But I made the videos about this in 2018, so I have following this for long enough time that I understand this. The reality is, can we build this? Yes. Can we afford it? If you want to spend $1 trillion on it, that's the reality of it. Every engineering firm, every scientist, which includes nuclear physicists now and electrical engineers, they're like, dude, you can do this. It's gonna cost so much money, it would be useless. So that's the reality of it. And so far, a system that's supposed to carry humans has not carried even a single human. Out of me making this video, as of now, not a single human testing I could find, not even a single one. And I'm reasonably sure if that happened, human testing, it will be all over the news. So far that has not happened, and yet people are like, yeah, India, my government was like, we're gonna spend 3,000 crore. That's a big amount of money in India to build this. I'm like, this is a human carrying system. It has not carried a single human. How the heck this system is safe for humans? Like Virgin Galactic is that they actually started to bring out products here and actually start to assemble things. You can check the video down below. But I'm like, how the heck you are doing that when nobody has pointed it out? Dude, is it safe for humans? It's like, to give you a context of the time frame we are talking about. In 2012, there was a dream that we're gonna have electric planes. Now electric planes are available, buying, and people are selling it and using it. And for training aircraft, for learning aircraft, the whole market is exploding, and that happened in 8 years. Hyperloop is just a hype. Yeah, they are building test tracks. None of the single test track so far has a human inside it. That should be your first red flag. On top of that, none of the system reach the speed. They are like faster than plane. None of them have even reached 800 kilometers or 500 kilometers per hour. So it's like, what the hell? That's the whole point. And no regards of like, how the heck you gonna provide the oxygen inside. And you don't have to provide oxygen over 20 minutes of the journey. You have to provide oxygen, you have to remove CO2, you have to do all that. No mention of that. And how the heck you gonna handle a fire inside the pod, because the pod will become like kill, so to say. And how the heck you gonna rescue things? Because you have to understand it. Every engineer designs their things, oh, nothing bad is gonna happen, but bad things happen. How the heck you gonna rescue in that scenario? Like, I'll give you a simpler example of tunnel, completely sealed system. You are talking about an English Channel tunnel that is going below it. There's trains going in, and trains are big things. What happens? Something bad happens. So they design tunnel in such a way they have two tunnels, not one big tunnel, two tunnels, like one up, one down. There is a third tunnel in center of them, which is called service tunnel. The whole idea is, in a case of a fire, because again, you can't expect people to walk for around 50-60 kilometers undersea. They will go into service tunnel, and rescue operators will directly come into the central tube rather than taking any train system. And the whole system is working perfectly because they have failsafe on top of failsafe, and you can just open the door and jump out. You can't do that in Hyperloop. So all these ideas, like, there is no plan, like nothing. We're gonna rescue passengers. How? Your tube is sealed completely. How the heck you're gonna have, either you're gonna have airlocks every few kilometers, again, even in few kilometers, how the heck you're gonna enter it and rescue the people, and making sure, because if you depressurize very quickly, you can damage the pod, or worst case, damage the people inside it. So that's the scam part of it. If you want to support it, here's the deal. Put a benchmark in front of you. I'm going to support the system if they test it on human, or I'm going to support it if they actually achieve the speed they are targeting. 1200 km per hour, 1400 km per hour, YOLO speeds. Let them reach that first. So that is why I'm calling scam. Can it be done? Absolutely. Can it be done cheaply? Hell no. So the first response, people who are like falling in love with this Hyperloop, they're like, but companies are investing in it and they are so smarter than you, so like, what do you know? Here's the there are many companies who are investing a lot of money into this, in testing and all that. They will tell you that that's what they are doing. There is companies who are developing what we call cooling systems for satellites. Here's the how the heck you have to test that? You have to test that in a very vibration heavy scenario. Why? Because rockets are very vibrating. They are very big vibrators. So you have to test that. How the heck are you going to test it? You can build your own test chamber, or you can just stick it on a test loop track. That is what they are using. They will flat out say, like we are designing cooling system for our satellites. So we think we are a good partnership. They're flat out getting publicity and a test system. Both of them cost money. So if they are currently in a position where they're like, if they will pay for Hyperloop testing, they will still make their money back. So that's why they are doing it. And flat out saying that, like, there are many companies, oh, this company is testing this out, this company is testing the electronics, this company is testing this. All of them are flat out saying it, they're testing it. It's like they do not care whether it works or not. Because why? Because they will get their knowledge out of it. They're like, we did this, like this vibration, this joint does not work, that does not work. They will know. Like that's the perfect opportunity for them. On top of that, whenever I'm talking about the public funded, there was like around $2 million spent just on studies on a system that has not carried a single human yet. So $2 million public taxpayer in India, 1,000 crores, and like actual products were imported and started to construction was began. So like millions of dollars. That's public money. That's your taxpayer and my taxpayer. That's like, think of it this way: if a government starts a project and it does not work out, government is not going to refund you the money. So your money, it's your loss. You are paying for it. That is why this kind of scams are very dangerous. Simply because people will say, "Oh, I'm not paying for it." No, you are directly paying for it. And if that money was sent into, let's say, normal systems, like, hey, just repair the damn infrastructure that we already have, it would have been yielded actual tangible advantages. But you're not doing that. And you have to know that there is a history of maglev systems and other hoo-ha systems that people thought it will solve all our issues. It did not. Like another example, this was successful, yet it was unprofitable. It became what we call a white elephant, conquered. Like everything in the system worked, but it was too damn expensive to run. So it happens. It's normal in engineering. Engineers want to do good things, like flat out. And you have to understand what's the Virgin Galactic's motive is. Like, yeah, Indian government is paying it. So if it works, Indian governments get something out of it. It does not work, they're gonna walk away. It's like, we already got paid, so you can't sue them backwards. So that's the reality of it. So please be mindful of it. Please be aware of this hype scam. Do not fall into it. And here's the deal: just have 3 simple test strategies. Have they shown you any way where, like, how the heck they're gonna rescue people if something bad happens? Because something bad always happens. Have they showed you like the actual humans inside the pods and tested? Then only take this seriously. And have they actually achieved the speed that they are selling you? Once they have done all that, then you'll realize that ticket price would be so damn high, it would be useless. So this was my kind of very ranty video, because this is the second time I'm making this video about hype of the Hyperloop scam, and people are still falling for it. Like Indian governments recently cancelled that project, and everybody's like, oh, India is losing money. The only country that can afford that kind of projects and still don't worry about money is Abu Dhabi. So, and yes, they are working on it. You have to understand this. It's just scam. Now, if you liked it or opened your mind, or like at least some thought, like you are thinking about some things, I'm happy with that. And please click the like button if you liked it. And if you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.